Hello everyone, I hope you are well. Last session I talked about redox reaction, the reactions that's containing electron transfers. They have 5 groups that today I'm gonna talk about them. So let's go. The first one, which is called combination reaction. A combination reaction is a reaction in which two or more substances combine to form a single product. You can see 3 examples of this reaction, and in each reaction you see formation of a single product. The point in these reactions is that in each reaction the oxidation number of the reagents and the products has been changed. For example, the reaction of sulfur with oxygen to produce sulfur dioxide gas, in which the oxidation number has been changed in the reagents and the products. The reaction of metallic sodium with chlorine gas to produce sodium chloride, and also aluminium with bromine to produce aluminium bromide. All of them, the oxidation number has been changed in combination reaction. Another reaction is called decomposition reaction. Decomposition reaction is the opposite of combination reaction, which is the breakdown of a compound into 2 or more components. For example, the reaction of the mercury oxide to produce mercury and oxygen. The reaction of potassium chloride to produce potassium chloride and oxygen are the examples of decomposition reaction. Combustion reaction or burning reaction is a reaction in which a substance reacts with oxygen, usually with the release of heat and light to produce flame. One of the examples is the burning of propane, a component of a neutral gas that is used for domestic heating and cooking. In which this combustion reaction produce carbon dioxide, because propane is an organic compound, and water. The main difference of combustion reaction and combination reaction is that in combustion reaction we have the production of flame, while in combination reaction we don't have it. Okay, displacement reaction is another type of redox reactions. In a displacement reaction, an ion or atom in a compound is replaced by an ion or atom of another element. Most displacement reactions fit into one of the 3 categories: hydrogen displacement, metal displacement, and halogen displacement. Let's talk about each of them in depth. Hydrogen displacement. All alkali metals and some alkaline earth metals, which are the most reactive of the metallic elements, will displace hydrogen from cold water. What does it mean? When you pour water on sodium, metal sodium, it immediately reacts with water to produce base and hydrogen gas. Calcium with water to produce calcium hydroxide and hydrogen. The production of hydrogen in these reactions is called hydrogen displacement. Many metals, including those that don't react with water, are capable of displacing hydrogen from acids. For example, iron, zinc, and magnesium don't react with cold water, but do react with hydrochloric acid to produce the salt and hydrogen here. As you can see, the rate of the hydrogen production depends on the reactivity of the metal. For the iron, in this case, it is slow, while for the zinc it is medium. As you can see, the number of the bubbles here. And for magnesium it is fast, because magnesium is more reactive than zinc and iron. Well, another displacement reaction is metal displacement. Metal displacement reaction. A metal is a compound. In a compound can be displaced by another metal in the elemental state. Here we see the example of zinc, metallic zinc, replacing copper ions to produce metallic copper here. Reversing the role of the metals would result in no reaction. In this case, copper can't replace zinc from the solution to produce metallic zinc. It's not possible. So how we can understand that a metal displacement reaction happens or it not happens? An easy way to predict whether a metal or hydrogen displacement reaction will actually occur is referred to an activity series. According to this series, any metal above hydrogen, if we consider hydrogen as a base, any metal above hydrogen will displace it from water or an acid. In this case, the first three lines respectively, they react first with cold water to produce hydrogen, with the steam, and with acid. All of them produce hydrogen. In fact, any metals, but that one is more important. But metals blue hydrogen, I mean copper, silver, mercury, or gold, won't react with either water or acids. In fact, any metal listed in this series will react with any metal below it. For example, zinc is above copper, so metallic zinc is able to replace copper from the solution and produce metallic copper. Well, what is the application metal displacement reactions? Metal displacement reactions find many applications in metallurgical processes, the goal of which is to separate pure metals from their ores. For example, vanadium is obtained by treating vanadium 5 oxide with metallic calcium to produce metallic vanadium and calcium oxide. Similarly, titanium also is obtained by reaction of magnesium, metallic magnesium, and titanium chloride. And we have metallic titanium here. In each, the metal that acts as the reducing agent lies above the metal that is reduced in the reactivity series. So calcium in this reaction, for example, acts as a reducing agent and it is above vanadium, so it can displace vanadium. Magnesium acts as a reducing agent and it is located above titanium, so it is able to replace titanium and produce metallic titanium. The last subgroup of displacement redox reactions is called halogen displacement. Another activity series summarizes the halogen's behavior in halogen displacement reactions. So if in this list I can also add fluorine, we have a complete list. Fluorine. As you can see, the reactivity from going, from down to above of this list, the reactivity increases. It means that fluorine is able to displace chlorine, bromine, and iodine. One example here is the reaction of bromine with iodide. Since bromine is above iodide, So it is able to displace iodide from solution and produce iodine. The displacement reactions here, they are finished, and another type of redox reactions is disproportionation. A special type of redox reaction is the disproportionation reaction. In this reaction, an element in one oxidation state simultaneously oxidized and reduced. Consider the decomposition of hydrogen peroxide to produce oxygen and water. If I want to write the reaction here, hydrogen peroxide to produce water, 2 molecules of water and oxygen. The oxidation number of oxygen in hydrogen peroxide is -1, and it reduced -2 in water, and it oxidized in oxygen from -1 to 0. Another example of decomposition reaction is the production of hypochlorite as a bleaching agent. So in this reaction, chlorine gas will react with 2 molecules of sodium hydroxide to produce sodium hypochlorite plus sodium chloride and water. The oxidation number of chlorine here is 0, while in sodium hypochlorite the oxidation number of chlor here is +1, and in sodium chloride it is -1. So as you can see, one reagent simultaneously is oxidized and reduced in disproportionation reaction. Next lesson, I'm gonna talk about how to prepare standard solutions in laboratory, and I want to talk about titration methods like acid-base titration and redox titration. So follow me for more lessons. See you soon.